Hello, everyone. Welcome. Thank you for joining us today. We are going to start now chatting about JavaScript security. Let me add that to the stream. There we go. Hello, everyone. Welcome to joining us. My name is Irantal, and today we're going to see a few videos and examples, hands-on live hacking of JavaScript security applications like Node.js and maybe containers. And there's going to be a bunch of them. Well, thank you for joining us. I'm going to start off with that. And I'll go ahead and introduce myself. My name is Liran Tal. I'm a developer advocate at Snyk. You are at the Snyk Live session. Thank you for joining again, taking the time off your day. So I'm a developer advocate at Snyk, and I'm on a mission to basically help developers like you, myself, my friends, colleagues, everyone over the world build applications securely using open source software. I'm actively working in the JavaScript and Node.js ecosystems, like different foundations, OWASP, Node.js, OpenJS, all of those stuff. I'm actively helping developers by building content, building best practices, all of those things. So if you have any questions, reach out. I'm happy to help and hope you learn a few of those kind of like what to do and how to avoid the gotchas and the pitfalls in this session. So thank you for joining. By the way, we have the chat. So if you're joining from things like the YouTube or the Twitch stream, feel free to interact with the chat. I'll do my best to monitor that as we go along. Let me push that in right now. There we go. So I'm monitoring that as we go, and we'll try to address everything in time. Well, let's get us started. So I would like to open up with this following questions. And what is the future of open source software security? I mean, people are talking a lot these days on supply chain security topics. So anything from things like typo squatting attacks. So for example, maybe you have been installing different packages which you, shouldn't have installed. For example, by basically just having a typo or just copy pasting to this, to the CLI, something that you shouldn't have. So typo squatting attack have been with us for years, and they're not actually a JavaScript specific thing. They've definitely have been hitting other ecosystems like Python and Ruby. And so other registries are not, safe from this, and they are a thing, but there are other kind of supply chain security things that we've probably seen, and we'll talk about here as well. How about malicious packages? Like there's specifically a malicious package like the Fall Guys ones, which is supposed to be maybe people think it's an SDK for the game and stuff like that. And maybe they'll go ahead and say, hey, that's pretty cool. I heard about this, so I saw it, somewhere. Maybe I'll go ahead and install it. And once they do, this is actually a malicious package, not existing anymore in the registry, but it existed for a specific period of time, and it was there. And if no one had noticed, this to report or find it, it would have just been there and available for everyone to, early install it. So we've had typo squatting, we've had malicious packages, but let's talk about other kind of supply chain security issues that we've seen, like compromised maintainers. Essentially, the ability or the possibility of a maintainer accounts, I maintain some packages on npm. I'm pretty sure some people here also do, and it's possible that maybe you or myself potentially may have our accounts on npm or github or otherwise, where you host your packages on the supply chain, could get compromised, maybe because I'm not using two-factor authentication, maybe because my password is very weak, maybe because I'm reusing an old password. So many reasons for, and some dark web ones as well, like maybe maintainers sell their accounts on the dark web, maybe. So a lot of those issues are part of it. And so while all of those are very valid supply chain security concerns, as developers, that we have to deal with them day to day. And while they're, they do happen, they are not the common thing that happens. They're mostly the drama stories that, hits the headlines, and most of us will probably not be subject to this. Even Event Stream, which was probably one of the most impactful and lasted for 3 months, it was still just targeting a specific set of developers for a project, which indeed end up, releasing some vulnerable, I would say, Trojan and backdoor packages, but that's the case, right? So what are we talking about today? You have to understand that as developers, our responsibilities and scope of the problems we have to deal with are a little bit more wider than it was before. And so if we're talking specifically about security beyond, performance, accessibility, and all of those things, we're talking about the attack surface actually getting extended. So where are the vulnerabilities if I'm building a JavaScript application end to end on the front end, on the back end? Where are they actually kind of manifesting? Or what are the places that I should be worrying about? And so without further ado, let me kind of like outline what we're going to be doing today. We're going to essentially hack a live Node.js application. Together with you, we're going to go and do that. So I am going to do in the next 30, 45, maybe the top of the hours, we have a bit of time here to go through this, hack an application together with you. Hopefully you'll engage in the comments and we can go through this together. How we're going to do this is very important because that is where we're going to highlight the attack surface. So first of all, we're going to talk about vulnerabilities of dependencies, which I think potentially it seems very predictable that when we talked about supply chain security and open source security vulnerabilities, we talk about dependencies. And that's something that we've definitely been accustomed to for a while. But I think what is maybe kind of like avoiding it or like unaware of for developers is how the fact that a vulnerable dependency, maybe deep down in my dependency, kind of like nested tree, how a vulnerability there actually manifests and someone can actually access it from the application by interacting with like, the API or my query parameters or just the web interface if I'm building, a JavaScript, like talking about a front-end app. How do they actually, manifest and exploit a vulnerability? So that is what we're going to see. And we're going to specifically like a look at Marked. It has a, bit of a story there, but also like interesting into like the source code of like why it leads to that vulnerability. Then we're going to talk about the fact that, well, JavaScript application, thanks to Node.js, can essentially run on the server side. So we're going to get that application containerized and we'll deploy to the cloud. Of course, we want to deploy it when it's a secure application and, not having many vulnerabilities in it. So, that's something we want to try out. So we're going to go ahead and containerize it. Maybe I'm going to need for this application a few open source libraries like ImageMagick and stuff like that to kind of like do conversion of images, which I don't want to do with Node because, single threaded and stuff like that. I want to block the CPU. So I'm going to try and do that. And while there are issues relating or vulnerabilities relating to the container image itself, there's actually a further level of potential security concerns where vulnerabilities can come from, which I think, developers may be kind of like not seeing very often. And I'm telling you, I haven't thought about that myself before, like thinking too much on this. And that is the Node.js runtime. So yes, the Node.js runtime actually has quite often a lot of security releases throughout the year. I think last year it had definitely more than like 8 or 9, so maybe a couple more. That's almost a security release for every month, and you have to stay on top of it. And what can happen when anyone on the web can interact with your Node runtime as a server? Well, since they have direct interaction with that, unless that's some job server, but if it's not, if it's like an API or something that's exposed, essentially every interaction goes through that. So unlike a vulnerable dependency or container, which may go unused, you're not using the vulnerable function or whatever, the Node runtime is always getting, processing those requests. So if there's a vulnerability related to that, something about the HTTP headers, something about just the interaction of like the HTTP request and whatever the Node runtime does with it, then your application is vulnerable. So like how many of you, just think about it for a second, when you're running Node.js servers on your backend, on your systems, think of it, which version of Node.js are you running right now? That's a tricky question because you may not know it. And if you do, you probably know the version because, well, I need ESM, I need, something new that was coming out, a new feature, whatever, policy, experimental policies, stuff like that. You may not, I'm trying to say these are the reasons you may know the version. You may not know it because it actually just had a security release. And that is something we should be cautious for. So if you're here with me, I want to thank you so much for staying along. I know your time is valuable. I appreciate it that you care about software, care about open source software, and software security in general. So thank you so much for being here. Of course, application security is hard. It's something we kind of like need to figure out. How do we do well? How do we teach developers how to do that? And so I want to make a point of like essentially how hard application security is. It's almost not thought of as like an actual requirement in many CS studies and universities. And so let's dive into one example. Now, I'm gonna go into the code right away. Everyone's probably anxious for all the demos and the hands-on live hacking. So let's look at this example. This is a Node.js application, which, well, part of a Node.js application. This is basically a function signature of an Express web application, which has request, response, and the next function there, callback. And what it does, as you could probably guess, it's probably trying to call the user table or collection, if this is like a MongoDB maybe database behind the scenes, to essentially, it looks like it's trying to do a login because it's actually going for like a username and password. So that could be it. That could be something that happens there. And I'm actually thinking in this with you, like once you look at it, like, just tell me, what do you think are the vulnerabilities that actually happen here? Are those sanitizations or command injection, or what do you think is going to happen here? And I'll leave it for a second there, and I'm gonna go and check out the chat. If there's anything there, you can feel free to add it. Okay, cool. All right, good stuff. And looks like this is Hacker Kyle saying, nobody teaches AppSec, which is, yeah, that's what we're here for. So thank you all for staying along, and that's a thing. Okay, I see more stuff coming in. So let's see. You can put whatever you want in username, and it will look it up. DB injection. That's true. So essentially, what we're seeing there is potentially a database, maybe an SQL injection or something like that. And then I'm going to take you to that, this isn't really an SQL application. It's a NoSQL one. So if you try to, put something like parameterized queries like for SQL ORMs, maybe you would have been able to kind of like countermeasure this. And this is not doing any SQL concatenation. So yeah, this could be susceptible, except this is a NoSQL injection. So any kind of like, if you just add or 1 equals 1, all of those ways to kind of like escape it, that doesn't happen here. That's like that wouldn't be just working as is. I see more ideas here, which is thank you for this one, Arjun, because this is a NoSQL injection. Why it is, let me show you. So let's thank you all for like also just interacting. This is great. We're all learning together. So most of the applications of the Express ones that you see people building with Node.js, they're going to have this body parser and app use, body parser for like the JSON middleware. And what it does, it essentially takes whatever you send it, even if you're sending like a JSON object, it's going to turn it into a JavaScript object. So if my input or like my request is going to have, when I do a login, for example, and that function handles it, if going back here, if that username or password from request body username as a variable, if that's going to be an object, like a JSON object, that's going to be a JavaScript object, like an actual one in the runtime. And so let's see what is the counter effect of that. It is actually going to put it right as is. And if you're using MongoDB, and MongoDB has those set of operators where it is, well, it is part of the language of like how you query MongoDB, except in this kind of case, if we're not specifically like casting username or password to be a string or stuff like that, if someone sends in an object, that's going to be a JavaScript object. This specific JavaScript object is going to tell MongoDB behind the scenes, under the hood, when it runs this query, to actually do a kind of like a greater than match, like a regexing kind of thing, to filter all the results. Now, you see exactly now how this is, in effect, a NoSQL injection, right? Because I can add username, send the request username as admin, and send this greater than as a JSON object for the password. It doesn't have to be a string. I can send whatever I want. So I'll send this object. And essentially, I'll be doing a NoSQL injection to this kind of a piece of code. So thank you so much for that, Arjun. That's very on point. Spooky from Hacker Kyle, thank you. That's probably a bit spooky. So I know what you're saying. Like, well, people sanitize, right? People cast strings. People use, I don't know, some sort of I would say, database schemas to, I guess, well, not database schemas, but schemas in general, for their input and output and APIs to just, I guess, provision kind of like a strong typing. Well, you'd think so. You'd want that to happen, but let's see. This is a vulnerability that I found, exactly the same thing, that exact NoSQL vulnerability actually happening for this app called Rocket Chat, which is an open source project, which has done amazingly well, and I'm happy for it. And it has gone into like commercial use, etc. That's great, and it's really coded in the open, which I love because I love open source communities. But it was Rocket Chat specifically had a vulnerability related to this. Let me show you the code for it. This is a screenshot I took from the exact code base and the exact commit that was vulnerable. You can see it on, of course, on like GitHub and anything else. This was a way, as you can see, this is like doing a similar kind of like query on the database, like user find one. It's taking params token, is essentially taking it from like the request and just putting it here. And if I was able to send anything from greater than, less than, maybe use some kind of like more ways to maybe exfiltrate more data and stuff like that. Well, that's kind of like what you don't want happening. In this case, this was an Nosql injection that was also like very severe because as you can see, it's done as part of the function method called get password policy. So it's actually an anonymous way to run arbitrary NoSQL commands because this wasn't behind any authenticated interfaces. So it's a very tough problem. And I think I love this from Aftinerd saying well, every CS curriculum in bootcamp should probably have covering security learnings and AppSec. So thank you for that. You're totally right, and hopefully we can teach and learn some of those things here. So let's go back to some of these things. This is, everything's kind of like an iceberg these days, I feel. But it's kind of true, right? Like all of my application is built on a lot of, open source software. And it's hard to deny that, right? Like open source code lies beneath this iceberg. If the top is my own code, what I write, that may be Nosql injection, which I hope some tool will help me find it. And I'll show you how you can actually do that. But beyond that, like we actually want to be able to concentrate on our work. We do not want to reinvent, frameworks like Fastify for Node.js, frameworks like Spring for Java. I don't want to rewrite that, but I need to accept that there's like 90% of my code base is with that. As JavaScript developers, I guess this isn't coming as a surprise to anyone because when you do like an npm install kind of thing, you're getting overwhelmed by the amount of vulnerabilities. I had to edit this number to like make it super big. But that's kind of like how it feels. And it feels a bit overwhelming, like the amount of it. But the very dangerous part of like working in this kind of mindset is that you accept the risk and you ignore those vulnerabilities. You begin ignoring them because you do not understand them. And maybe you do not know how to fix them. And maybe, something just doesn't work for you. And that's kind of what I want to show you, like, how do we fix that? How do we help developers fix their vulnerabilities and why they are important, okay? So if we take this example bit of code, which can come from one of the dependencies that I have in the project that I'm going to build today, is I'm going to leave it also like for a few seconds there. When I tell you about it, see if you can spot the code injection vulnerability that hides here. But essentially, once those vulnerabilities become publicly known in this Dust.js LinkedIn dependency that I'm using in my project as like a template engine, what happens is they become publicly known. So the first thing you want to do as a developer, as a a stakeholder of the application, is know about them so you can take actions to basically upgrade and fix it. Patch them if you can't, or something else. Maybe even migrate away from this library to something else. So all of those are really important. So let's go with that. Here is your mental exercise after we've seen that. You essentially really just want at this point to imagine that you're building an application. This could be JavaScript, Node, Java, whatever. Your mental image of this application is very much focused on the code that you write, right? Like your business logic, how you use the dependencies. You spend hours debugging it, etc. But the reality is a little bit different. It's the fact that all of those NPM packages that you import and rely on from community-powered code from essentially strangers out there, or, well, if you use my libraries, I hope I'm not a stranger anymore. But we need to take them under like specific risk. We're leveraging this beautiful open source world. boosting our productivity, but at the same time, potentially introducing some risks that we should know about. And we've all known and seen how open source has just grown, right? Like 2019, 2020, 21, and 2022. Right now, there are about 1.8 million packages on NPM. That's an insanely amount of like a big number for open source packages that I, as a user and developer, can consume and use to build my open source project. I'll tell you which graphs, though, you haven't seen probably yet. And that is this one. It's the trend of finding more and more open source vulnerabilities in open source software. It's something that it needs to be mitigated by anyone, I think, who owns, maintains, or uses open source software and NPM packages, for example, in this session, in one way or another. So let's go back into a bit of like this open source supply chain security story. Okay, what's going on here? We've seen some of those cases happen, right? Like Event Stream, as I was giving the example to begin with, had this case of someone kind of like socially engineering their way into getting involved into the project, spending some time on the project. But essentially, when they was kind of like integrated by the owner, they had been acting in a very malicious way by adding a dependency that they control. At the time, it was okay, but then of course they changed it. They released a new version, and now when you install the Event Stream back then, 2018. It was actually pulling in one of those nested dependencies called flatmap stream that had actually a backdoor, a Trojan in it, and specifically targeted developers of like this Copay cryptocurrency wallet. So that company actually ended up releasing a couple of versions that were having that Trojan, which you could easily guess that it was like just stealing money from people. And it happened due to open source, due to the fact that Event Stream, which I did not hear about before this incident, is a nested dependency of some other popular packages like Webpack and like other projects. So while you may not know the package itself, it may have millions of downloads, which it does, and it did. And it's getting used, through all of those open dependencies that you may have. So it's something to think about, and it actually raises this context of, well, maybe we can do something a bit more to do a bit of due diligence when using open source packages. Like maybe when we want to use a package like Moment here, we actually want to go and check, like, is this popular? Other people are using it. Are they trusting it? What's the maintenance like? Is this getting active commits and issues and people opening and merging pull requests, or not really? Kind of like maybe going stale, and I should maybe avoid it because if it may have a new vulnerability reported to it in the future, will there be a maintainer and a team to actually push fixes? Well, that's something that we should really care about. So, and I haven't even talked about whether that actually has security vulnerabilities and which specific branches of the versions are actually vulnerable now or not. So like you would have a matrix of seeing which you could move to. A lot of this is, so this tool makes a lot of this vulnerable. It's called Snyk Advisor. You can see the website below. It's basically snyk.io/advisor, and it helps you get like this kind of like 360 view of the package. As you get and choose a specific package, one of the things that might kind of like be something that keep you up at night, if you're like me a bit, is understanding that managing dependencies for some ecosystems is super complicated. And one of the research highlights that we've seen in the past was the fact that understanding the dependency tree and where vulnerabilities come from is not that easy, and it changes. So if you go to like the NPM ecosystem, you could see that, or JavaScript in general, I guess, more than 80% of vulnerabilities that Snyk users find when they test their projects are actually coming from indirect dependencies. Now think about it for a second. Those indirect dependencies, you have zero control of them, right? Like they are coming from maintainers and nested dependencies down the trees, and they decide which dependencies to add, which versions of those dependencies. There's some control depending on the ecosystem. There's some control in terms of NPM has this kind of like, and Yarn has this like resolutions kind of package JSON entry to it, which helps you say, I want to actually pin even that nested dependency to a specific version. That may or may not work depending if the new version, for example, that is fixed, had actually not broken the API for the dependency that uses it. So it's a complicated task. Now, let me show you a bit more code, and like let's see what happens and what kind of vulnerabilities can happen with dependencies. We'll specifically take a look at this use case of which we're actually going to hack later. So I actually want to give this as a practical example. Let's imagine I'm building an application, okay? And on the front end side, what I really want to do is have this input box for to-do items that I want to add. And I want to add something to it, and I want to be able to parse it as Markdown. So essentially, what I really want is to use Markdown parsing, but safely. So I'm not going to actually write my own Markdown parser and all of those stuff. I think I'll find something there. And there's a package called Marked, and that is actually very, very popular, downloaded millions of times and so on, as we'll see later. Let's see how it behaves if I try to add something like this example JavaScript alert as part of trying to exploit it. Mind you, this specific Markdown library, when we look at it at the code, it actually does have a sanitizer built in for that specific version which I'm using. Later versions have taken different decisions, but this version which I've used in my project here actually does have it. So I turned on sanitizer, and let me show you. We'll walk through the code of like how that works. So essentially, marked as a dependency has this function on the prototype available called link. What it does is, of course, it tries to parse the link and display it as like an HTML one rather than a Markdown one, because this is for the web. So it has this href value passed to it, and if you look close enough, I've highlighted here, it actually does some internal sanitization or like filtering, trying to say, hey, if the value of this href variable actually starts with things like JavaScript : or VBScript : and like those are vector of attack, just add XSS, cross-site scripting, essentially adding JavaScript. Someone can add JavaScript to the page itself, which we do not want to do because we do not want to have them control the page for users. So it has this kind of sanitization for it. This is a good start. Is it enough? I don't know. Well, let's say. It has this other way of escaping the href value. So you can see that even before it goes that, it actually does some decoding of the URI and tries to kind of clean it up. Why does it do that? Well, let's look at what does unescape do. So essentially, you could have HTML entities representing specific type of like symbols or characters on the web. So if you've done, for example, modern React or Angular or Vue or Svelte or whatever on the front end, you know that if the user input that you add into like the JS6 code has like script with like the Angular brackets and stuff like that in it, and they do something there, it won't run. Not because of a JavaScript error, but because there's safe output encoding that encodes the Angular brackets of like a script and whatever other HTML elements into actual like textual representation on the website, on the DOM, and not creating a DOM element like an actual one that the website will actually try to render as an object. And so that is what we're trying to do here with this code. The author of marked is trying to replace that signature for the regex, for the regex, the regular expression here, is actually trying to match all of those potential HTML entities and clean them away. And we'll see how exactly that works, or maybe doesn't work. So keep that in mind. We're going to drill down into like the demo now. And so kind of want to say, while that is completely something we should worry about these days, kind of like we're lucky to have things like Snyk bots and stuff like that help us stay on top of security vulnerabilities, right? Like whether these are like automated requests coming from Snyk or like the CLI or whatever, we're essentially entering a world right now where the example that I showed you before, if like actually both of them, right? Like if you had code issues or if you had dependency issues, we're entering a world where security turned on by default is something that us as developers are now used to. We accept that as de facto, and that is good because it means the second thing that's important here is tools, developer security tools are now adapting themselves to developers, to the developer's mindset, to the developer's workflow. It's not the other way around. And that is the most amazing thing that we're seeing these days coming as a change to developer security. So with that said, what is that bigger attack surface that we were talking about? Let's explore this more in practice. And I see Arjun asking on the previous vulnerability that we've seen. If it's a prototype pollution attack, it isn't. If you want to learn more about prototype pollution attacks, I think you can just like Google that, add maybe a Snyk to it at the end. You'll probably land on like a Snyk learn lesson that we have about this, which is amazingly well curated. So I completely recommend that. So let's go back to this. When we are saying, we want to build cloud-native applications, developers are having their application stack at our attack surface a bit more than just the application code itself. What does it actually mean? Well, let's say you scan your application, your project, essentially, not just the application itself, but the project itself on Git. You import it to, from GitHub to Snyk, etc., and you scan it for security vulnerabilities. Why would you want to do that? Well, of course, because you kind of like want to audit your dependencies, maybe even like get like an SBOM kind of like view of which dependencies you have and all of those things. And when you find vulnerabilities, you actually want to fix them, right? So how do you know if you are not vulnerable to a new vulnerability after you fix the project? That's the thing, right? You go ahead and monitor it by importing the project to Snyk. They actually get monitored for new vulnerabilities and new CVEs, whether on MITRE, but also those that aren't being reported in the wild. That Snyk has some Intel database behind the scenes that tracks all of those kind of like signals and noises and filters those out, curates them, and tells you if there's a new vulnerability you should know about. So essentially, you've done all that. You're now monitoring it, and essentially, you've gone into a baseline of these are the vulnerabilities that you have. 0. Amazing job to you. Well, this is to myself, but really to everyone here. So thank you for doing that. And so what I actually want to say here, if you've got to this point, this is really good. And I want to say congratulations to myself. But there is something of a misconception here that, I'm missing something. And this is what it is. It's the fact that my application that I built doesn't actually live, just on the repository. It doesn't actually live to be on Git. It needs to be deployed somewhere. And so if this is a Node.js application that I want to deploy in the cloud, I probably want to also make sure that I build it. How do I build it and deploy to the cloud? You're right. I'm probably going to be doing some kind of like, container stuff. I can have different ways. Like I can deploy it as, serverless functions. Essentially, there are many ways of doing cloud native stuff, for developers, where they want to do small APIs functions, whether you're doing front end and you're just deploying stuff to like Vercel or Netlify, and let them worry about SSL and stuff like that. But if it's a microservice, or I don't know, maybe just a monolith or whatever, but it's like a backend things. For me, it's like very easy to just go ahead and containerize it. So that's what I'll do, and that is that reserved blank space is for. Okay, that is the fact that essentially, when I imported the Git repository, it had different stuff in it. It had my package JSON and my package log. It has my dependency manifest, but it also had a Dockerfile. And a Dockerfile adds some metadata about it. Let's see. It adds some stuff like, where am I, what am I basing this node image? It's based on maybe stuff like the node Docker Hub image that you officially want. But what does it have in it when I use from node? Which version am I actually taking? For a long time, there's been a lot of vulnerabilities that existing on popular images that we kind of need to be a bit more cautious of, and always scan those container images for whatever vulnerabilities they have. But it's more than that. Like maybe it also has specific tooling and libraries that I need to install for, from the OS itself, like ImageMagick, or maybe this is like a backend thing that clones repositories, so it needs Git, or it needs SSH, or it needs curl, or whatever. Those may be vulnerable, and if unsanitized input gets passed to them or whatever, they can be, a point of attack. We'll see how it is. Also, the fact that maybe I'm just installing dependencies and resolving the versions in runtime, because this is like a bad practice of installing dependencies on your container. And let's not forget what we said in the beginning. We said there's going to be a node runtime in my application as a Node.js application that could have a security vulnerability attached to it. Am I actually upgrading container images of Node because I'm actually looking at security releases and updating all the time? Or am I not doing that? So you should, and we'll see why. So we talked a lot. Let's do some hands-on stuff. Let's do some hacking for Node.js packages or apps. We'll do all of the stuff into cleaning container or whatever. So we'll start with marked. We'll drill down, like we said, to the container itself. and maybe show you a bit of how do you hack a node container from the node runtime, and what does it mean? Do you have access to like environment variables and path traversal and whatever? Like this is, let's say. So I'm gonna check if there's like new chats. Okay, cool. I'm gonna try and monitor the chat a bit more as I'm gonna go into hands-on stuff. But yeah, if you have any questions, just shoot it in. So let's see what we're gonna start off with. I am gonna go and make sure we have the app running. So I'm gonna use some windows here. I've started the MongoDB app before, so you can see this is all Mongo stuff on my Docker container. And if I do All right. I don't know who of you hacked me from Node runtime, but that was successful. Congrats to you. Okay, cool. Looks like we are back. Yes, that's true. So let's go to it. I'm gonna move this one. Yeah, there we go. So in the meanwhile, at least this was helpful because I was able to start my application here and it got connected. So let's see what's up. And we'll do a couple of like really speedy hacks to just make up for the time here. So I've got the app. Let's see what's going on. I need this over here. Let's go to the app, see that it's up. 3001. There we go. So hi, everyone. Give me input on add here. Give me input to add here to the demo. This is a to-do application. It can be anything from hello or gender, or we can say is this half Tamayo. But I'm going to use Markdown like that. And then you see it bold. This is what the marked library does, okay? I'm using marked in my app. I'll show you quickly. This is the Node Advisor stuff. Marked. It has, well, 100 over 100. This latest version is like super great. It's like 400, no, 4 million downloads just this past week. It's pretty well maintained. Last commit 2 days ago. If community is pretty well, it's pretty active. It has a README code of conduct, stuff like that. Let's look at this. Popular, yes, this last version, the popular version, number 4, is pretty good. If you're on version 2, which you can see is not that long ago, it's like 2021 June. That's like not even a full year by now. Some people might be here on some legacy applications. Remember, Marked is also. I think this version is also. Yeah, it is. It's used on the front end as well. So be sure, please, to upgrade. But anyway, we're using a different version, and I'm using that in my code. Let me show you how I've made this possible. Let's see what we have there. Marked. Yes, so this is my app. It's end-to-end JavaScript stuff. I'll make it a bit bigger. I know you kind of need to see this through. There we go. I've got Marked here. You can see it over here. I'm using, I've got all the time running the VS Code extension for Snyk. So it's up here, finding a lot of like code security issues in my own code and open source. So there's like a bunch of them. We're not going to go through everything, but that's why it is telling you already when you require it. It's annotating and telling you, hey, there are 11 vulnerabilities I detected here. Of course, because this is a vulnerable application, so I can show you what's going on. So I've done sanitize true, and I'm giving that to my view, and that's how I'm rendering out output. Now, how do we get issues coming up here? Let's do like we did before. Markdown stuff, example, and then HTTPS example.com. If I do this and just add a new website, it works. I can click on it and I'll go to that website. You could see it on the bottom left here, right? But if I try to do something like a JavaScript malicious input, essentially a cross-site scripting, that doesn't work. It's kind of, we see it's breaking up. If I try different things, it's also breaking up. And we've seen why it breaks up. It doesn't work really well because there's like sanitization built in to Marked, right? That I actually enabled. By the way, I needed to know to enable this. So if none of you here had told me that I needed to enable it and I just run it, well, I'll probably be in some troubles just by like the small stuff. But I did. And I know that I need to like now escape this because I can read Marked source code. So if I go and I start replacing some stuff for HTML entities, like I think this is and hashtag 58 semicolon says that to the browser, you need to replace this with a colon. And when you do that, essentially it will be rendered like this. And then it becomes a valid link. And that's interesting. Let's try that. And let's try to do it for more of the stuff that I have here, like a closing, round closing bracket thing, parenthesis, has this kind of, okay, I need to like remove one of them. Has this kind of HTML to let the browser know that they need to do that. Let's say add it. Doesn't work. It looks like all of my attempts to hack the application don't work really well. So what can I try? Well, let me tell you this. If you literally put the word this here or document, just add that to the payload. Let's see what happens. I'm going to copy paste it so I don't need to re-enter it. And now it's not broken anymore. It's not gone. It just exists. I'll paste again so you can see it. This payload is essentially 58 HTML entity number. I didn't put a semicolon. I just put the word document, which is a valid JavaScript statement. If I click on example, we get an alert 1, which is exactly what we wanted to do. And it shows you how this is vulnerable. If you go back into something like scanning it with my repository here is called Goof. This is all of my stuff. What you're saying is like the Snyk app. If you haven't seen that before, it shows all of my projects. One of them is Goof, right, which I imported from my Git. And you could see when importing, it already detected some stuff that it can help me fix vulnerabilities, like things like code analysis, like my Dockerfile. So this is like SAST, Dockerfile containers, package.json. If I go into the package.json, I can see that it essentially has detected a bunch of stuff like Mark is here. I can search for it. You could see it already filtered it. Actually, my version of Marked in this application has a bunch of vulnerabilities in it, different types of XSS vectors that are impacting it. You can see exactly, which versions are vulnerable. How do you fix it? Actually, open a pull request to fix this vulnerability. This will actually happen automatically when you just start off. If you want to get more details and like see what you need to do, why is marked vulnerable the way that it is. There's even like more information here. If you don't know what a cross-site scripting vulnerability is, you can just right-click this, open this new this new episode to learn about what cross-site scripting is. So it's completely free, available to everyone. You can just go ahead and just skill up on learning about security. It's also interactive. It's pretty cool. I'm not going to go into this, but this is amazingly cool, and I super recommend to just visit the Snyk Learn lessons and just skill up. By the way, it has a great prototype pollution. There we go. Here, of course, if you want to go into that and like understand those. So let's go back. Let's rewind. We talked a lot about stuff. We've seen how essentially I may be vulnerable now to an XSS because of this vulnerable dependency. But we also said that we wanted to try and see what can we do more than this? What is more impacting on my application attack surface than just vulnerabilities? And we said, let's build this app or a different Node.js app, doesn't really matter, as a container. And well, what do container security issues have that I need to worry about? So let's see that and like kind of like slide and shelve this whole app on the side here. And let's go into a different app that I have. Container breaking in, this is the one. I think I've got that already opened on, let me go back here, on like a different VS Code stuff. Let me get this a bit smaller just for a second so we can run this. And what I need to do for that, essentially, let's close this one. And I need to stop this container. Let's stop the MongoDB from running here. And I'll close this one so we don't take up the port as well. And what I essentially want to do is be able to, well, I want to run this, but let me show you before that what happens. So what you're seeing now is essentially a Docker container, or sorry, a Docker file that builds a Docker container. And what that Docker container does is it helps you understand, or it helps you define how this application should run when I deploy it. What dependencies it needs. Does the npm install does that? What OS should it start with? All of those things. So not going to do a Docker kind of like a learn exercise here, but if you've seen that before, this is like simple enough for you to understand like what this application does. That's great. Let's go with this. Please never build applications in Docker like this specifically. There are a lot of bad practices here. Just for simplicity, we have a blog on this. I'll tell you about it in the end. But before that, let's build it. So I'm going to go here to the CLI again. I want to make sure that I've already built it. I did like the whole build like that. I called it RCE, basically a remote code or command execution, which should give you a hint of like what's going on here. But before that, I actually want to run it. So like after I've done that, I want to be able to say it's 3112, right? 3112, yes. So I actually want to be able to say, hey, I want to run this up. It's running. 3112. Okay, running. Localhost 3112. It's running, telling me cannot get something, doesn't work. Why does it not work? Let's see. Well, my whole code for it, as you can see, there's like a server.js and a bunch of stuff. It's actually pretty simple. Let me turn off the, make sure to see it a bit. Move out the terminal and show you. This is a very simple Express application that allows you to upload files. It has use of like the path, the f, and the child process, because what it does is once it listens on the port 3112, it actually allows you to interface with a /public HTML content, static content, basically a form to allow you to upload pictures. And what it does is when you hit that submit button, it actually use that Multer package on NPM here on my package.json to basically upload this picture and use a child process exec file to execute a system process. This is, by the way, a secure way of using that, not just concatenating a string input to the command, and calling convert, which is, I've learned about it and see that this is a way of doing that. So I've done this. And I'm calling convert, and then I'm going to go ahead and resize it to a specific output. So essentially, this is just like a job server, not even exposed to the internet if you didn't want to. Maybe like an internal microservice interacts with it, submit the form, and just resize images. Let's see what happens, OK? So I'm going to go back into the CLI for a second and show you. I've got this container running to show you that it's actually running. I'll do a Docker PS. You can see that this is RCE. We just ran it a minute ago. It's listening on that port. Actually, maybe just connect inside the container itself. So I'll do docker exec -it interactive terminal to basically open, that's kind of like SSHing into the container running, if you kind of want to think of it like that. You can see it has all of those files, my Dockerfile, my server.js, everything that I just showed you, right? Dockerfile, you see the exact same thing that I showed you before. You could see server.js, that's the code that I showed you before. All of those things existing here. Okay, let's see what's going on now. Let me show you all the files again, and then I'll interact and upload. Go ahead and upload something here. Choose file. So have something on the desktop. My Yoda picture, let's do that. So when I upload this picture, I do resize. Well, it's funnily enough, this isn't my Yoda hat picture, which I know some of you were like keen of like maybe seeing here, but something else happened, and that's what I want to show you. Let's look at what is that picture has in it. So going back over to the terminal here, to desktop, and then looking at the picture. First of all, it isn't a JPEG one. It isn't a PNG. It's an MVG. So I don't know if you knew this, but apparently this is another way of defining, declaring what is the contents of the picture. It's called a delegate. It's a functionality that ImageMagick has, which I've no idea of like why it has that, or did not know it existed before I learned about this vulnerability called Image Tragic. Because let's see what happens. When I look at how this picture is built, it's not just binary bitmap stuff. It's telling it in actual, plain text, how does it want to build that that pie that you've seen right now, the pie chart. I'll go through the end of it, and I'll show you what's actually happening here. I've actually been able to use the fill command to like add a URL to this to basically put more contents into the picture, except I'm actually using an improper input sanitization vulnerability. I'm exploiting it, that it exists in this ImageMagick version of the convert CLI that allows me to run commands, whatever I want, basically. So I'm running touch, hi, whatever. And because the node CLI in this code base over here, because the convert CLI is actually taking that as input, doing something with it, it's actually processing that picture. Who doesn't process pictures these days on modern web, right? So if I go back to the file listing here, what I would expect to happen is I would want to see a file named like that, because that's essentially what it did. Let's see if that worked. A bunch of demos here. Okay, so it looks like it did. There we go. That file, which was not created before when I did the ls command, and now I've essentially ran a command on my container. So this is someone who essentially has their maybe dependencies are great in shape, no vulnerabilities, or they fixed it. Maybe they also have fixed their own code and stuff like that. But essentially, their container was left kind of like unattended to. The Docker image was left unattended. There are a lot of open operating system kind of like libraries, like Convert, like ImageMagick, like, I'll show you something even more fun on this. Going back to the code base over here, if you look at my Dockerfile, look at it. It's actually not even installing. It doesn't have this kind of like run apt-get install ImageMagick. It doesn't have it. You know why? Because that is actually built in to this specific image, node 610, which I hope no one is actually using, because that's like pretty old and end of life. But it actually has it as part of this. So you may not even know that which version you're using, not even taking like a proactive way to install it, but you are still vulnerable if you use it. And this quite have easily have been anything else that you might be dependent upon, whether that would be, again, like things like the Git CLI, the Git binary, the curl one, the SSH, whatever you're doing inside containers, maybe as part of like the application, like a job server, whatever, that would still be vulnerable. That is something you should be careful of. So I'm gonna see if we can do another speedy demo of reaching the top of the hour here, but I think we can maybe crank that up. So let's say we've done this, and we're went back into the time machine, went back into the year where we had node 6, and we said, hey, node 6, okay, we kind of need to upgrade this from node 6, or I don't know, node 8, right? That's kind of like that seems to be LTS, long-term supported even numbers with Node.js, like Node 6, Node 8. That makes sense. Node 5, 850 is essentially the latest version at that time. So let's try and use that. So if I do that, and I'll try to build this again. So I'll need to get out of this and Docker stop. T, there we go. And I'll go ahead and rebuild this. So Docker build RC. Let's rebuild it. We've basically just changed that once, the node one. It doesn't have a lot of cache to use because we've done a basic change there, but a lot of stuff ended really quickly. There we go. So the next thing that I want to do is rerun it. Run. There we go. I've just changed that kind of like that sort of Docker image. Didn't do anything else to the application itself. Like if I go here, it still works. I can tell you without having the time now to demo it, but I can tell you if I upload the same image, it essentially got resolved because we changed versions of ImageMagick, and this current ImageMagick version at least doesn't have that vulnerability, which allowed us to run remote command executions on this container, running container live in production. But it has something else in it, and that is something that we should be careful of. So if I did that, I did Node 850, but maybe Node 850 has an actual vulnerability in it in Node itself, in the runtime. And so to save the whole time, I'm going to copy and paste one of those exploits that I have. Essentially, let me do that. It's this one. I'll put it on the top and add it over here. What this does is, I'm curling from my own machine to this running container. You can see the same port, etc., public, but I'm masking this %2e, which essentially means .. I'm masking it with an unexistent folder and applying the same .. kind of like folder on top of it and trying to get to the etc password. I don't know if that's like enough on the hierarchy. Let's see if that works. Okay, amazing. So what we've essentially done is we're now able to access data, file system data, on this exact running container. Like if I logged in, you'll see the exact same password file. I can do more than this. I can actually access my own server. Let me share the other exploit that I have. This one, which actually access source goof server.js. So access, does this look familiar to anyone? Right, that's our own source code that we have containerized. Someone is able to access this just by running this exploit of a query. Like, why does that happen? So let's look at this for a second. Now we're on time. If you have like a few more minutes to spare us, I'll explain exactly what it is. Node 85 security. I guess security is probably enough. We'll find this. Look at this. There's actually a path validation vulnerability existing in version 850 of Node. So the fact that I'm able to just run curl and access path traversal and basically access files on the system of this running container is not due to like Express itself, or not due to the dependencies that I have, or even the container image is not related here. This is the fact that Node as a runtime, there's a vulnerability with the core path module. Remember the one that we've had in our application over here, used it underlyingly, that kind of like the whole stuff here aggregates and makes that kind of vulnerability possible. So hoping that you kind of understood all of those type of vulnerabilities that could actually impact our application. And so with that, I'm going to kind of summarize this whole thing. Let's see if we have some questions. I'm going to summarize, and if you can wait, that's great. I'll be here to answer them. So let's see. Some takeaways are, on the Snyk blog stuff, we have a bunch of best practices, anything from like NPM, Java, like how to write secure code, SQL injections, path traversal, typo squatting, malicious packages in Java, JavaScript, Python, some PHP stuff. Go for it. There's like a ton of information of like really practical advice of how to avoid all of those things that can go wrong. Do it. I highly recommend, please. The other thing, let me move to the next slide, is that Snyk Learn that I showed you. That is a pretty cool way to just learn some stuff, because it's like really small, bite-sized kind of like courses on anything from like SQL injection to different stuff. This is even like, I think, a bit of an outdated screenshot, just because we're now covering a lot more ecosystem than just Java and JavaScript and Kubernetes. So the team is running really fast to build this. they're very interactive and really fun to go through. So that's like a really easy way to just skill up. And as a developer, just learn to be, just learn a little bit more about application security, and you'll be like, a great developer after that. So I'll leave you with those as takeaways, and we'll cut the top of the hour. Thank you for staying along. Thank you for all the questions, for going through this, through these interactions with me. I'll go through some of the questions in the comments, and let's see what we have there. And if you want to stay, that's great. So let's see. Let's see. Bunch of stuff there. Well, let me see this one. Aftamayo says, so we could actually. There we go. A lot easier, less distracting. So we could say the upload image application is vulnerable to the local file inclusion, I guess. The input is improperly sanitized. Correct. You're talking about the second demo with the container, I guess. So what happens there is there's a vulnerability. I'll actually reshare my screen just because I want to show you this one, like that. So if you look for image traffic that actually has that's the exact name that this one specifically has. It actually even has like its own website that explains what's going on. What they did that when the security researchers disclosed this, because they wanted to make the impact of how important it is to find out about this. Now the thing is, if you go to the Snyk app, it would show you that it has all of those things. If I'm going to go here and say, hey, you know what, this is my Dockerfile. I think here in my Dockerfile, I probably have a different version than I have locally here. In my demo, but it's kind of the same story. So I have here, with my Dockerfile here on Git, I actually have node 6 stretch instead of node 6 something wizzy. And as you can see, it has like an insane amount of vulnerabilities, right? Like 1,000 of them. If I filter for image magic, you can see there's almost, there's exactly 250 of them. Just different vulnerabilities, right? Like one of those, this is null pointer dereference. There's different stuff, out of bounds. One of those is essentially that improper input sanitization, which exists in that image where ImageMagick processes it. And the thing is, what I'd really want from a tool like Snyk or a developer security tool is to tell me, hey, you're using this image. This is your current image. It has this amount of vulnerabilities. But you know what? You can lower the attack surface very easily by 50% if you just go and upgrade to node 16. But we understand maybe going from 6 to 16 might break things. So we are actually recommending you alternative upgrades. Maybe you can go to node 12. That's a little bit less. It's a slimmer image. It also has a considerably less attack surface. Also, all the vulnerabilities are just low, not even critical, high, or medium. That's amazing. I can just click open a fix PR. What it will do is it will go to my repository, which I'm that's why I imported this from GitHub, and it will go and just simply replace from node, whatever it is. This is the node 6's stretch. We'll replace that with this, and that's it. I can run that through my CI, and my CI at that point can actually take a look and see if if something breaks. I know it at that point, so I can maybe try to switch to a different one and so on. So it's an amazing way to basically just trim down a tremendous amount of vulnerabilities, not by guessing it, but by getting actual data that helps you make those decisions. So great question, Haftamayo. Let's see what else. What is this one? Well, no. What else? Yes. What a cool curl payload. Thank you. That was nice. It's all, by the way, open source. You can get that from the Snyk Labs repository. Just ping us. We'll get you all of that. Oh, I'm seeing Aftinerd actually added some stuff here. So if you want to go and learn anything about our best practices, skill up, etc., that's the Snyk blog. It's there. What else? Oh, there we go. I think that's pretty much it. So I am going to thank you all a bunch for staying along. Thank you so much for running through this with me. I really enjoyed everything about this, learning about security with you, learning about technical issues through this time. So thank you. Be secure. If you need anything, just ping us. We're here to help. And that's it. Have a great time.